Greetings and welcome to Week 3, Unit 2 on Open Electives. Open Electives is one of the curricular components, and in the previous unit, we understood the nature and role of projects and internships. In this unit, we'll understand the nature and structure of open elective courses and the many possibilities that exist to take advantage of this particular category of courses. What are open electives? The concept of open electives in Indian undergraduate engineering program was introduced as a part of the choice-based credit system and further emphasized by the National Education Policy NEP 2020. These open electives can be designed to meet the requirements of multidisciplinary and holistic education and attain many of the PO6 to PO11 program outcomes. For example, till now, what many of the institutes are doing is they will ask each department of the college to announce some courses which they can offer to students of other departments which do not require serious understanding of the that particular branch, so that they will get some idea about that particular branch. Whereas we can look at this, not only that kind of courses, we can look at another three categories of courses. One is called service learning course. The other one is courses that address multiple intelligences. And the third one is human technology interaction. We can identify courses under each of these categories, and the departments can choose whether they would like to offer, especially in many private universities where they have all kinds of disciplines addressed or degree programs offered. It should be possible for them to identify very interesting courses under all these categories. Let us look at what service learning course is. Service learning is an educational approach that combines learning objectives with community service to provide a pragmatic, progressive learning experience while meeting social needs. These courses are ideal for attaining professional outcomes like ethics, environment, and societal impact. These have been around for quite some time elsewhere in the other parts of the world, but even in India, some institutes have tried to offer so-called service learning courses, and they have been quite successful as well. So it is not something absolutely new. But when you design a service learning course, you have to follow some rules and understand the characteristics of effective service learning courses. First thing is the participation of the students should be measurable. It is just not announce a course and they do something and then you give some grade. That means the contribution or work of the student can be assessed through specific assignments, projects, or reflections. Mind you, that word reflection also becomes very important in this. Then you must also have realistic targets. It should be, that is, in the time that is available to the students and to the department, the goal should be achievable, realistic given the time and resources available. If you have a lot of resources, of course, you can do many things, but within the resources available, the goal should be achievable. And then they should be relevant. It should not be something like very hypothetical type of situation. The participation should connect to both the academic content and the service experience. And it should be specific, clearly define what students should know, understand, and do. Link academic knowledge with community needs. Because if you take some hypothetical and go and impose something on a community, they are unlikely to relate to that. So it should be, first starting point is what does the community need? And now you link to that your academic knowledge. And reflective, encourage critical thinking and personal growth. When you look at any community needs, what happens is the community, what they want, what they expect to happen can be quite different from as a student what you understand or the faculty understand. So first thing is you must be able to understand what the community needs, and that requires critical thinking. Means, are we making some assumptions because of our own thinking process or what we have read, or does it sit with properly with what community requires? Okay. What are the typical components of a service learning course? Clear learning outcomes linking service and academics. Learning outcomes should be very clearly stated. We'll see some examples. Community partner relationship and a memorandum of understanding. You can't just arbitrarily go into some community and start talking to people. You should be able to establish this kind of relationship. What is the how is the community organized? To whom should we talk? Who can help us in participation? And somehow with that organization, you should be able to have a memorandum of understanding so that the community feels that the department which is organizing is serious about it. Orientation skills training before community engagement is initiated. That is, the student should receive some training before they start interacting with the community. You can't just arbitrarily go and ask whatever question that comes to you. One should be very sensitive to ask some questions that are likely to offend the community members. And define roles and schedules for service activities. Regular scaffolded reflection. That is, every time you interact with the community, the student should start recording their own, creating their own journal or record their discussions and continuously follow what they've been, how they're interacting and what their experiences are. That's an excellent experience when you about reflection on what you are doing. And assessment of student learning and community impact. Finally, what is the impact that has been created? It should be more on that rather than some theoretical aspects where you conduct a written examination. It should be based on what has actually happened. On everything may not be successful, but did the students learn something on the ground? That is what is important, and that is what should be assessed. Now let us look at some service learning courses. We will not write all the what you call course outcomes of this, but broadly, sustainable rural technology. Focus is engineering for the bottom of the pyramid. Bottom of the pyramid means people who are the poorest, who are least empowered, and they have least resources. How do we help them? For example, what is the service component in such a course? Students work with local village panchayats to identify bottlenecks in irrigation, waste management, or renewable energy, or something else. The department should do some homework working with some local village panchayats in trying to prepare the ground for that. Learning goal is applying engineering principles to low-cost, high-impact solutions. And the professional outcome, if you look at, PO7 will be attained through this because it is related to environment and sustainability. Then you have another example of service learning course is assistive technology and disability studies. Focus is designing for accessibility and inclusion. Focus is that because people will have age wise they have different requirements, and some people are disabled in some way and they have special needs. So the service component is students partner with the local NGOs or special needs schools to design and or repair customized mobility aids, sensory tools, or software for students with disabilities. For example, people with different disabilities, different NGOs exist for people who have hearing problems or people who are blind. They have different requirements. So there are NGOs already operating in that area, and one can plan a course like this with the local NGO so that you can readily interact with them, understand their requirements. The understanding universal design and human dimension of engineering. That is the learning goal. Universal design means anything that you design, let's say an artifact, engineering artifact, it should be usable by people with regular average person as well as people with disabilities. That is what is called universal design. Can we do that? Universal design is a concept that has been floated by architecture department, and that means people when they try to access a particular public building without special assistances and so on, can they navigate that building? And can we design it in such a way that people who are have issues with their either blind or either hard on hearing or they have walking disabilities, can they navigate the building? The professional outcome is engineer and society, that is PO6. Okay. So what happens by using these courses, you are now coming into you're addressing some of the POs which are not easily addressed by the regular engineering science and engineering courses. Then you can think of community information systems, digital literacy and e-governance. The service component is students help local government offices or small community businesses set up digital record keeping, basic websites and cyber security protocols. Can they meet the requirements of some small community or local government office? Learning goal is data management, networking and user experience design for non-technical users. So this is going to address professional outcome of PO8 and PO11 actually, not 12. That is lifelong learning is PO11 and and ethics. Then you can also think of a course like disaster management and mitigation. Focus is resilience and civil safety. These days, especially the disasters are happening on almost regular basis. Is the society is resilient to handle such kind of situations? How do you prepare ourselves for that? So here, service learning part, students work with local disaster management cells to create hazard maps, conduct fire safety audits in slums, or develop community emergency response plans. Learning goal is risk analysis, structural integrity, and logistics. And you are looking at safety and public health, which is also related to PO6. Now, another example of service learning is tech education outreach. STEM education for underprivileged youth. This is not something new. People have been voluntarily doing, several students do that from various institutes, but it can be more structured if it is offered as a regular course. Larger number of people can larger number of students can participate in this. Service component is engineering students teach basic coding, robotics, or science through toys at government primary schools. A learning goal is breaking down complex concepts and learning how to learn and communication skills. Professional outcome of this is PO 9 and PO 10. Sorry, the PO 9 and PO 10, the numbers may be slightly different. Okay. Now, those are some examples. It doesn't mean that you have to do exactly the way the courses are given. You can design your own course depending on the local requirements or where you are physically situated, what is accessible to you. You can design a service learning course. Now, there is another dimension, what is called theory of multiple intelligences. It was proposed by Howard Gardner, a Harvard psychologist, in his famous book of 1983. It's called Frames of Mind. The core concept is that traditional definition of intelligence, usually measured by IQ tests, that those tests focus on logic, mathematics, and linguistics. It is too narrow. Instead, Gardner argues that humans possess at least 8 distinct intelligences that represent different ways of processing information and solving problems. All these intelligences will also come under the category of cognitive science. The basis for this is, let me first list the 8 intelligences. Linguistic intelligence, that is sensitive to the meaning and order of words, and people who are poets, journalists, public speakers, they are good at this. Logical and mathematical intelligence, the ability to analyze problems logically, carry out mathematical operations, and investigate issues scientifically. Engineers, scientists, and mathematicians. As you can see, we only focus mainly on these two. Then you have musical intelligence, skill in the performance, composition, and appreciation of musical patterns, pitch, and rhythm. Composers and musicians. We all enjoy music, and you know, all around you there are several people who are very good at music, but occasionally they go through some music degrees, but many of them seem to be learning by themselves or by practice or from some gurus. But it is not part of the, let us say, an engineering curriculum or a general program. So some people have that intelligence, you can say, because of their genes or whatever it is. They start at a certain point, and they don't have, if they're participating, let us say, in an engineering or a science type of degree program, they don't have a chance to even explore this dimension. Because if somebody says they want to learn a little bit of music, then they'll say you do it as extra activity or join some other kind of program. Then you have bodily-kinesthetic intelligence, the potential of using one's whole body or parts of the body to solve problems or fashion products. This, at least there is some dedicated programs like dance, theater, or physical education programs, and so on. People who are athletes, surgeons, dancers, they have a much better bodily kinesthetic intelligence. Then you have spatial intelligence, the ability to recognize graphic. Spatial intelligence is the ability to recognize and manipulate the patterns of white space as well as more confined areas. Here we have, as you know, architects, then you have graphic designers, then you have interior designers and so on. They have the ability to recognize and manipulate the patterns in a given space, for example. Then you have another very important intelligence called interpersonal intelligence, the capacity to understand the intentions, motivations, and desires of other people. Teachers, teacher or teachers have to have much better interpersonal intelligence. If they don't have this, they cannot become good teachers. Salespeople, religious leaders, they seem to be understanding the intentions and motivations of other people more readily, either by sometimes intuitively, sometimes they train themselves for that. Then you have intrapersonal intelligence, the capacity to understand oneself, including one's own desires, fears, and capacities, and to use such information effectively in regulating one's own life. This everyone requires, but we never get trained for that. Some of the gurus and spiritual leaders try to give you that. In whatever way that you can improve your intrapersonal intelligence, it is always good for your life. Can we go ahead and do that? Then he has identified, Howard Gardner identified another one called naturalist intelligence, expertise in recognition of and classification of the numerous species, the flora and fauna of one's environment. Biologists, farmers, they have this particular naturalist intelligence. Now, one can say, why not add more intelligences? What Howard Gardner says, there can be more, but based on the kind of knowledge that comes from very detailed over several decades work in the neuroscience, they have been able to identify some specific regions in the brain where these intelligences can readily reside. Okay, so if you focus on that, that intelligence can be trained. That is the idea. The key principles of the theory is everyone possesses all 8. Every person has a profile of these intelligences. While we may be exceptionally strong in one or two, we use all of them in varying degrees. Let's say you have 8 dimensions now. There may be more. Maybe in future, neuroscience will identify maybe more intelligences. But as of right now, 8 are identified. And we have ability to a little extent in each one of them. And not only that, intelligences work together. In real world tasks, these intelligences are rarely used in isolation. For example, a dancer uses musical intelligence to follow the beat and kinesthetic intelligence to move. So they combine the two. Okay. For example, I may not have any musical intelligence, but to the extent that I enjoy certain type of music. So we may have a little bit of musical intelligence, but not. But our capacity is in some other area. Then a person can be very high in one intelligence, but low in another. Like musical, one can be very high in that, but low in another, like logical and mathematical. There is always this debate of nurture versus nature. While there may be a genetic component to these intelligences can be developed and strengthened through education and practice. That is what it is. Actually, there is a lot of work going on in this area in the West, maybe even in some schools in India, that people try to identify what kind of intelligences the children have, and whether you can design your school programs in such a way that whatever they're good at, whether that can be encouraged through the program. Okay. Let me give some sample courses for spatial and visual intelligence, whereas for the The logical, mathematical, and linguistic one, we have many standard courses. We don't have to talk about that. For example, engineering is inherently visual, but these courses push beyond the standard CAD into creative visualization. Design thinking and visual communication. There are courses already available in India for the past few decades. The focus is using sketching, 3D modeling, and infographics to communicate complex ideas. It may not be the preference of all students, but if certain courses are carefully selected and made available, some percentage of the students may opt for it and grow in this particular area. Activity is creating visual narratives of how a machine works without using words. Can I create some visual narrative? That is the purpose of visual communication anyway. Another course, architectural appreciation and urban design. For example, understanding the relationship between structures and the space they occupy. Mapping urban flow and heat signatures in local neighborhoods. It will be an interesting course, whereas even a mechanical engineer or a civil engineer, students can opt for a course like this. Bodily-Kinesthetic intelligence. Intelligence is critical for the hands-on engineering and ergonomics, like rapid prototyping and model making, and ergonomics and human factors engineering. These courses do exist, but they can be designed in such a way students from other branches of engineering can actually participate. And musical and rhythmic intelligence. This is what generally in engineering college or engineering institutions, you don't find courses like this. But universities which offer other programs, including dance, music, and other performing arts, they can work with engineering departments together and think of building a course like this. Acoustics in built environments. How sound wave travels through different materials and shapes. So you understand theoretically about that, and then you design the soundscape of a noisy campus cafeteria. How do you soundscape that? Then audio engineering and music production. This many students are likely to be interested. Engineering focus is signal processing, electronics, and software engineering. Musical intelligence is understanding pitch, rhythm, and timbre and harmony through digital manipulation. Again, this will not be the preference of all engineering students. People who have some level of musical intelligence may prefer to work in an area like this. Why not? It makes the education much more holistic. Here some more courses. I will not read through all of them. Physics of musical instruments. That is mechanics, material science, and vibration analysis. And the activity is designing a 3D printing a hybrid instrument. Can you actually design an instrument? So physics of musical instruments is one course. Musical robotics and algorithmic composition. Even right now, some students attempt to compose music using the present AI tools and do that. And you can convert this into a kind of a formal course as well. Okay. Students will, if it is properly planned and offered, the motivated students in this direction will greatly enjoy this kind of course. Again, if you offer a course like this, only a small percentage of your students are likely to be interested. So if you offer a large variety of courses, then students have the option of selecting what they prefer and where they can contribute. Then you have psychoacoustics, the science of hearing. I will not go through the detail. Then you have soundscape design and noise control. This is an interesting thing as far as I'm concerned. How do you noise pollution on campus and designing an acoustic garden that uses water features or wind chimes to mask traffic noise with musical intervals? This will be an interesting one if your institute is very close to the like a highway and there is a lot of traffic and traffic noise. Then you can design what we call an acoustic garden. History of technology and music, musicology for engineers, even that can be an interesting course. Now, let us look at sample courses for interpersonal intelligence. Essential for the human dimension and teamwork, obviously. And actually, interpersonal intelligence is the most required one for any practicing professional, because you should be able to work effectively with a group of people, and it cannot be what do you call, you cannot judge everybody from your own perspective. One should be able to work with them, interact with them, and avoid conflicts and so on. So you have a collaborative project management. An experience can be given to the students how to, at least hypothetically as a part of a course, how do you collaborate with a group of people and achieve your goal together. Then you have a technical sales and negotiation. If you want, management department can help in designing such a course, and it's good for engineers, because many times a project engineer in civil engineering or mechanical may have to explain to clients as well as other stakeholders how can we communicate to them unless you are having good interpersonal intelligence. Then you have intrapersonal intelligence. This also completes what you call as a holistic person. It directly supports learning how to learn. If you are able to understand yourself, you can achieve the goal of, let us say, both the ethical dimension of your profession as well as how do you, for example, in lifelong learning. This itself will give you fantastic experience examining one's own values against the impact technology like AI and big data. This is the most current one, whether we can look at this whole thing from various perspectives together. The students can together argue and say, can you arrive at something? But there is no definitive conclusion as of today. As you can see, there is plenty of literature that is coming saying that supporting AI and threatening that AI will overtake humans and so on. The activity is essentially maintaining a reflective journal on personal career goals and ethical boundaries. Then another course in intrapersonal intelligence is mindfulness and cognitive resilience for engineers. Naturalist intelligence, if you look for courses, environment and sustainability, there is what is called biomimicry, innovation inspired by nature. There are plenty of things one can learn from nature and try to imitate that. And similarly, climate change and disaster mitigation also will come under this naturalist intelligence. So these are courses coming under the category of multiple intelligences. They give you, if a department faculty together can plan this, they can make it happen. It will take some time. And if you have access to a corresponding specialist, beautiful courses can be designed and offered. And one thing is for sure, once the students opt for that as an elective, they will greatly contribute to this, and the purpose of achieving all the professional outcomes will also be achieved. Now, another category, which partly we have already seen, is the human technology interaction. That is, many courses suggested under social sciences can also be offered as open electives, because there we had a scope for only 2 courses in that area, in that curricular component. The remaining courses can also be offered as open electives. Like some additional ones we are suggesting, one is soil, food, pollution, migration, taking care of the world. These courses can greatly help students understanding the contexts of engineering problems, address higher order cognitive levels, learn to work as teams, and prepare for good and meaningful employment. All of them have excellent opportunity for this. By offering such courses, you are greatly enhancing the employability of your graduates. For example, take something like food. Food is, there is a lot of technology associated with that. It is not about agriculture. I'm giving only one possibility under the category of food. You can have different set of course outcomes depending on your interest. This is one set of course outcomes. We name it as food. The course explores the intersection of food systems and engineering through the lens of human interaction. It covers the evolution of food technology, the cognitive and sensory perception of food, the design of kitchen and tech interfaces, and the ethical and environmental impact of industrial food systems. We have plenty of industrial food systems where we are paying heavy price for some of them, and obviously food becomes now very important issue with regard to maintaining your health as well. Let us look at a few examples of the course outcomes of such a course. Explain the evolution of food processing technologies and their impact on human civilization and dietary habits. Okay, we have been processing food right from early times. That is, you take some grain and pound and convert into a powder, or you use some fruits and extract oil out of that, and you deep fry. These kinds of things have been there for several millennia. Okay, but that kind of technology is growing very fast, and that's why you have all the time new type of food items appearing in the market. Analyze the psychoacoustics and sensory interface of food consumption to explain how humans perceive flavor and texture. Design a user-centric digital interface or job aid for a modern smart kitchen appliance using human factors engineering. Many of you might have followed, people have been trying to design a chapati making machine for a home. And people have announced, made some, but somehow it hasn't, it didn't get the required traction for it to come into a middle class home as yet. Apply principles of thermodynamics and fluid mechanics to model the efficiency of domestic versus industrial food preservation systems. There are programs where the entire program itself is on food technology. Such programs already exist. So the knowledge does exist. But now how do you bring it into an engineering program and make it interesting for the engineering students? For example, evaluate the ethical and societal implications of food automation and AI-driven nutrition tracking on human autonomy. Then assess the environmental sustainability of diverse food supply chains using life cycle assessment tools. See, something like, as of now, with processed food, 30%, almost 30% of the food produced is wasted. Collaborate in a multidisciplinary team to develop prototype proposal for a low-cost assistive food device for elderly or disabled users. Plan a self-directed research project on future food technology, a 3D food printing, and reflect on its personal and professional relevance. Okay, this is just a sample course on food. And another course is on migration. That is, more than anything else in the world today, migration is happening extensively, both within a country and between countries as well. Between countries, it becomes strongly political, and within the country, it creates a whole set of issues which even now in India, for example, government is constantly trying to address. So the course examines the role of technology at the interface of human migration, both internal, rural to urban, and international. Students will explore the digital lifeline, the ethics of biometric surveillance at borders, the use of big data in predicting migration patterns, and the design of fintech for remittances. The course emphasizes engineers' role in creating inclusive, ethical, and sustainable systems for displaced and migrating populations. The thing is, if you are unable to create a lot of employment at village level, people will migrate to slightly bigger towns and cities. That you cannot prevent. They have to earn their living. And that kind of thing is not available in the villages, then they will migrate. So migration now becomes a regular issue, and accompanying that, there are lots of other issues will come. Whether you can address through a course on the migration itself. So here are some sample course outcomes of this. As I said, these course outcomes are not unique. You can evaluate them, and maybe a group of people can sit together and sit with sociologists, people who are in population studies, sit with them and identify a course where the interaction between society and technology can be the focus of such courses. Okay, what we have given is there is a lot of potential for the open electives if you can make use of them. And through these courses, we are talking of only 9 credits. They can be offered as maybe 4 courses or 3 courses of 3 credits each. 4 courses if you have, then you may have some as 2, some as 3. But it gives you a fantastic opportunity to meet the goals of NEP 2020 in terms of making it multidisciplinary as well as holistic education. I have not included courses like yoga and other things. They can also be considered under this. Okay, in my opinion, the open electives do offer a great opportunities to kind of close some of the gaps that exist in the current programs that are offered as engineering. And in the next unit, we will look at the nature of skill enhancement courses, which is also an important part of the engineering program these days. Thank you for your attention.